In this video, we are going to study about Cooky number. The Cooky number was the homework of the last class, but few students were asked to explain about this Cooky number, so I am just explaining to you. Cooky number means nothing but look at this. Input number is given as 5063. 0 can be in within the number. It should not begin. The number should not begin with 0. So if the number is in between or at the last anywhere without the beginning place, then it is considered as Cooky number. Okay, like for example, if in the program, if the number begins with a 0, okay, for example, and also let us say 7 here, okay, and also if there is no 0 present in that, also it is not a Cooky number. Another thing is what, if it begins from 0, okay, like 0543, then this number is not a Cooky number. Okay, number can be within the numbers. Okay, 0 can be within the numbers, but it should not begin with 0. And also there must be one 0 in the whole entire n number. Okay, now let us see this. I hope you understood about this Cooky number, right? If the digit 0 is present in it, then it is a Cooky number. And at the same time, the number must not begin with 0. Okay, two things you have to keep in mind. Okay, this is not a Cooky number because it is beginning with what here, 0. The same way here, look at this. If the digit 0 is present in it, then only it is a Cooky number. Okay, a number is said to be a Cooky number if the digit 0 is present in it. Okay, the first number is a Cooky number because 0 is present in it. The second number 7453, there is no 0 in it, and so it is not a Cooky number. At the same time, the number must not begin with 0 also. So there are two conditions in this program. Okay, now as you all know up to here how to write it, right? Okay, I have taken a variable count and a reminder to extract the numbers one by one, and then n1 is equal to n means to duplicate the number, right? Okay, now let us begin this program. Okay, we can since we have a number to be extracted, we use this while loop n greater than 0. Okay, tab tak n number 0 hoga, so till then it keeps executing. Okay, now the next one is what, to extract the number, reminder is equal to n modulus 10, your familiar formula, right, to extract the numbers. That means, for example, 5063 is divided with n, for example, n is equal to, this is your first input, right, n is equal to 5063. Okay, so n is this number, dividend, and the divisor is 10 here. 5 tens are 50, and then 6, then 3 also. So here there will be 0, and then 63 means 6 times. Okay, and then remainder is 3, but the quotient is 506. Okay, so remainder will be, this 3 will be stored in the variable remainder, right? Now listen very carefully. I'm just using a condition like this: if remainder is equal to 0. Does we have, or do we have 0 here? No. Okay, so this is only that if the number is 0, okay, then I've taken a variable. If this condition is true, then count plus plus, or we can say count is equal to count plus 1 also you can say. Okay, only if the condition is true, only count plus plus. Okay, remember that. And then after n is equal to n divided by 10. Okay, n is equal to n divided by 10. I am just closing the curly brace here. Okay, then finally, if count is greater than 0, then system dot out dot println, you can write n1 plus is a Cooky number, else otherwise system dot out dot println n1 plus is not a Cooky number. Okay, close the curly brace. Okay, now look at this. since there is up to here you understood, right? Okay, now look at this. Remainder is what here? 3. So is 3 is equal to 0? No, false. 3 is equal to 0? False. Will the count add any number to it? No. So it comes down to this next n value, and next n value is n is equal to n divided by 10, that is 506. So is 506 is greater than 0? True. So then remainder is equal to n modulus 10. Now n value is what here? 506 is divided with 10. How many times it goes? 5 times are 50, and the remainder is what here? 6. Okay. We will have this quotient as 50. Okay, and the remainder is what here? 6. Okay. Now when the remainder is 6 here, is 6 is equal to 0? False again. Will count add any number to it? No, count is still the 0 now, right? Okay, n is equal to n divided by 10. The next n number is what here? 50. 50 is divided with 10. 5 tens are 50, and the remainder is 0 here. Yes, we got one of this. Remainder is 0. So remainder is 0 is equal to 0. True. So if the condition is true here, then count plus plus. Count plus plus means count is equal to 0 first. 0 plus 1 is equal to 1. Okay, so this is your count value. Okay, this is count. Okay, count is equal to what now? 1. Okay, now the n value is now what here? 5. When 5 is divided with 10, 0, 0, and you're getting the remainder as 5, quotient is 0. Okay, here is 5 is equal to 0? False. Okay, will count add any number to it? No. So n is equal to n divided by 10. N divided by 10 is what here? 0. Is 0 is greater than 0? False. Is it going to add any number here? No. So finally, when this condition is false, it jumps on directly here. If count is greater than 0, what is count here? 1. So 1 is greater than 0. Yes, the condition is true. So n1 is what here? We have hidden the original number, that is 5063. 5063 is a Cooky number. Okay, like this, with this coding you try for the next number and this number which I have given also. Okay, and so you will understand this coding very well in a very easiest program. Okay.